y'all, so what we're going to be talking about this week is the normal curve. So this is the last part of our stats unit. So we're going to start with some vocab. So the first vocab we need to think about is the mean. And remember, the mean is the average of a set of data. The next thing is a new word. It's called the standard deviation. The standard deviation is how spread out the data is. So it says, like, do I have the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? That would be very spread out. Or do I have the numbers 4, 5, 5, 5, 5, 5, 5, 5, 5, 5, 6? That means they would be more condensed. So there would be a larger standard deviation for the first one and a smaller one for the second one. And the last thing is normal distribution, which is a bell curve that looks like this. So this is our normal distribution curve. So we're going to be talking about the properties of a normal distribution curve, which is, again, that curve right there. So the first thing is it has symmetry at its center. So notice how there is this line in the center. That means everything on one half and the other, if I was to fold it at that line, it would be the exact same. Which means that 50% of the values are less than that line and 50% are more. Because all of this inside here is the data. And you will see if you ever look for normal distribution curves in real life, they all, for the most part, follow this normal curve. If you look at my grade book right now, it follows this curve. Some people might have zeros, some people might have over 100, but the majority of people are in the middle together. And also, the mean equals the median, which equals the mode. That means at this center line, this is whatever value this is the mean, so the average. It's the median, so the middle, and it's the most because it has the most things. That is why it's so tall up here. And these little numbers at the bottom, they are the standard deviations away. So there's 3 standard deviations away from the mean. So this -1 to this +1, that's 1 standard deviation. This -2 to this +2 is 2 standard deviations. And this -3 to this +3 is 3 standard deviations. Note there are still some things happening on the outsides past the 3s. Those are something called outliers, so it's things that are not normal. So therefore, it's not a lot of the data that is there. So it's not counted in those standard deviations. So we're going to look at a couple things and see what we can figure out. So this is talking about these two curves have the same standard deviation, so the same spread out of the data, and different means, so different averages. So which curve do you think has the larger mean? Should have been curve B. Curve B has the larger mean because notice how it is further on that number line than curve A. So that tall point is further along. Now we're going to look at some other ones that have the same mean and different standard deviations. So that means they both have the most or the average at the same, but their spread out is different. So which curve do you think has the larger standard deviation? Curve D. The reason you know that is because it's flatter. That means there's more data that's spread out. Whereas curve C is more concentrated in the middle, where you see that really high peak. That means the standard deviation is not as spread out. So it is smaller. So we're going to try to figure out, so what exactly is a normal curve, or what isn't a normal curve? So I want you to look at each one of these things and tell me, is it normal, is it not normal, and tell me why. So first, curve A. Is it normal or not normal, and why? Curve A is normal. It's symmetrical, it looks like a bell, which these are called bell curves, so that one's good. What about curve B? Curve B is not normal. Curve B is something we would call skewed, because you'll notice it's not symmetrical. So this curve is skewed to the left. What about curve C? Curve C is also not normal. It is symmetrical, but it has those two peaks, and that's not what a normal curve is. A normal curve is concentrated in one area. And our last one, curve D. So curve D is not normal either. It looks like it should be until you look at the very tails at the end where they kind of do a little loopy thing, which means it is not normal. So we're going to do an example. So notice we have our normal distribution curve. So pretend we have a set of data with a mean of 45 and a standard deviation of 8.3 and is normally distributed. That basically means it has the bell curve. Find each value given its distance from the mean. So first of all, what number on our curve does the mean go at? What do you think? It goes at the number 0 because it's in the middle. If I was going to go from 0 to positive 1, what do you think I might do with that standard deviation of 8.3? I add it. So each time I go, I add by 8.3. So 45 plus 8.3 gives me 53.3, plus 8.3 gives me 61.6, plus 8.3 gives me 69.9. So that's going to the right of the mean. What if we're going to the left of the mean? What do you think we're going to do with our standard deviation, our 8.3? We would subtract it. So to the right we add, to the left we subtract. And we do the same thing, we subtract each one by 8.3. So what if we wanted to find plus 1 standard deviations from the mean? What do you think it is? It's 53.3 because you go plus 1 from the mean. What about plus 3 standard deviations from the mean? 69.9. You start at the mean, you go 3 to the right because it is plus 3. What about minus 1 standard deviations from the mean? 36.7 because you go left 1. And then what about minus 2 standard deviations from the mean? Minus 2 is 28.4. So that's how you find those different things. There's one other thing that we need to talk about with our normal distribution, which is our empirical rule. So with our empirical rule, it is 68% of the data will lie within 1 standard deviation of the mean. So that means all of that purple is 68%. The reason it's split and it has those two 34s is because remember it's symmetrical, so we can split everything. And this chart is going to make our lives so easy when it comes to anything. Because this normal distribution curve, all these numbers I'm giving you right now, never change. So no matter the distribution curve, they are all exactly the same percents. So if it's 2 standard deviations away, it is 95%. And if it's 3 standard deviations away, it's 99.7%. And then those little tail ends are 0.15 each, I think, if I remember. So we're going to do an example with this. So the battery life of a graphing calculator is normally distributed with a mean of 600 hours and a standard deviation of 100 hours. So first we're going to label them. So first, what is our 0? 600. All right. So then what about our plus 1? We add 100, it's plus 2, plus 3. All right. What about our minus 1? We subtract 100 and get, all right, minus 2. Minus 3? Yeah, so we're just adding and subtracting our standard deviations. Now it gets a little bit trickier. So we have the same exact thing, except now we're going to use that empirical rule. So, oh, I spelled rule wrong, whatever. So I'm going to superimpose the empirical rule here to make your lives easier. I highly suggest you write this curve down because this curve will help you for everything for the week. So, we want to know between 600 and 700 hours, what is the percent that we're going to find something? So what do you all think if you had to make a guess? Well, 600 and 700, I just highlighted that right now. That's 34%. So that's the percent. If your graphing calculator had that much battery life, it's a 34% of all the calculators made. What about if we were looking for between 400 and 500 hours? What do y'all think? So we start at 400 there. We go all the way to 500 there. So we have to add those two things together, and we would get 13.5% because we have to add those two things together. And lastly, greater than 700. What do you think we do for this one? So we start at 700, everything greater we highlight, and we want to add them all. So we add 13.5, 2.35, and 0.15, and we would get 16%. So with our normal distribution, with that empirical rule, all you have to do, the first step is you have to label. So like we did, first step is you label all your standard deviations so you can figure it out. Then you want to write in the numbers. So between 1 and -1 would be your 34s. Between -2 and 2, you put your 13.5, your 34, 34, 13.5. You can literally just use this chart, and then remember there's 0.15s at the end, and all you have to do to this chart would be to add your mean and your standard deviations. The percentages never change. All that changes is your means and your standard deviations. So this is what we're going to be working on this week. Please write this chart down, or honestly look up the empirical rule for normal distribution on Google Images, and then you'll see a lot of the same thing, and that can help you. So if you have any questions, make sure you are asking. I hope you have a great week.